Space is full of wanderers, planets with no suns, drifting like cold embers in a black ocean. Astronomers call them free-floating or rogue planets. We've found signs of these loners in the Milky Way by watching gravity bend starlight. A technique called microlensing. Microlensing happens when a massive object like a planet passes in front of a distant star, bending and magnifying its light due to gravity. It lets astronomers detect dark or hidden worlds, even rogue planets, without seeing them directly. But here's the twist that breaks the comfortable model of our solar system. What if one of those rogues wandered in long ago and stayed? What if a hidden world, massive, dark, and distant, still tugs at the edges of our architecture? For years, strange orbits in the far reaches beyond Neptune have whispered the same rumor. Something heavy is sculpting them. Some simulations point to a Planet 9, an unseen giant on an elongated, tilted path hundreds of AU from the Sun. Others argue the pattern is a mirage of small number statistics and survey bias. The debate is fierce. The stakes are beautiful. Either there's a missing planet we haven't seen, or our methods need a hard reboot. Both outcomes push science forward. Tonight, we'll track the evidence in 5 clean steps. The signals, the physics, the suspects, the counter-arguments, and the search that could end this mystery. The distant objects beyond Neptune, such as Sedna and 2012 VP 113, travel on elongated orbits with perihelia so far from the Sun that Neptune's gravity should barely touch them. Yet many of them appear to share similar angles in space. A pattern difficult to produce randomly. Simulations show that a massive unseen planet could herd these objects into these alignments and could even gradually nudge some of them into orbits that cross Neptune's path. However, large, well-designed surveys like OSSOS and the Dark Energy Survey show that once you fully account for where telescopes looked and how detection biases operate, the clustering may vanish, meaning the pattern might be an artifact of observational choices rather than a hidden heavyweight pulling strings. The result? We're in a scientific stalemate, and the next many years of deeper, unbiased surveys should decide this. In the young days of our solar system, space was crowded and chaotic. Dust, gas, and newborn planets swirled in a violent dance. If a rogue planet passed through this thick gas disk, friction could slow it down just enough to let the Sun capture it into a vast, stretched orbit. This early disk drag is one of the most realistic paths for a foreign world to become a permanent member of our solar system. Sometimes capture is more dramatic, a gravitational trade. If a rogue world approaches a binary system, one object can be ejected while the other is trapped in orbit around the Sun. This binary exchange doesn't need gas, it's pure gravity doing accounting. It might explain how our outer solar system could have gained a distant massive planet while tossing out another long ago. Another powerful mechanism is the stellar flyby. The Sun was born in a dense stellar nursery, packed with hundreds of sibling stars. A nearby star passing within a few hundred astronomical units could tug the outer disk, lifting orbits, and maybe handing us a drifting planet from its own system. This would explain strange orbits like Sedna's, whose distant path looks sculpted by a passing hand. Each of these scenarios, gas drag, binary exchange, or stellar flyby, has a low probability on its own. But given the billions of years and countless encounters in our galaxy, the odds aren't zero. Free-floating planets are common, detected by microlensing across the Milky Way, meaning the supply of wanderers exists. If one was captured, it would orbit far beyond Neptune, on a high-inclination eccentric path, too faint to see except in infrared light from its own leftover heat. This is the invisible frontier astronomers are exploring right now. In the case of Triton, Neptune's largest moon, the retrograde orbit and the active youthful surface revealed by Voyager 2 mark it as a strong capture candidate rather than a native moon. The model suggests Triton began life as a Kuiper Belt dwarf, was perturbed into Neptune's gravitational influence, and then swapped in through a three-body interaction, becoming trapped. Elsewhere, the giant planet swarms of irregular moons, many tilted, eccentric, even backward orbiting, are textbook signatures of capture. Combine that with the dynamic upheaval described by the Nice model, which explains how the outer planets migrated and scattered small bodies everywhere, and one plausible scenario emerges. What if a hidden giant, one of a few to tilde 1020 Earth masses on a vast hundreds AU orbit, wasn't born here but captured? While it remains hypothetical, the simulations and infrared archival searches are real. The search for the planet that shouldn't exist is reaching its final stage. The Subaru telescope continues scanning the farthest parts of the sky, capturing long exposures of faint, slow-moving objects that could reveal the unseen giant. Each observation rules out huge regions of space, narrowing the possibilities with mathematical precision. These patient hunts are building the foundation for the coming revolution in sky mapping. Next comes the Vera Rubin Observatory. Its large synoptic survey telescope will repeatedly image the whole visible sky with such depth and frequency that any faint planet, drifting silently against the star field, will be caught in motion. Every patch of the heavens will be photographed hundreds of times. Patterns will emerge, and hidden objects that once mocked discovery will reveal themselves through slow parallax and patience. Above Earth, NASA's Nancy Grace Roman Space Telescope will widen the horizon beyond our Sun. Its micro-lensing campaign will measure the frequency of rogue planets in our galaxy, teaching us how often such loners exist and whether our solar system might have captured one long ago. Every gravitational flicker, Roman records, is another page in the story of cosmic wanderers. In 2025, astronomers at the European Southern Observatory announced that they had observed a rogue planet forming at an astonishing rate, a young world gathering mass without orbiting any star. This discovery proved that free-floating planets are not ghosts. They are living, evolving entities shaping themselves in darkness. Such findings give weight to the idea that our solar system could once have captured a similar drifter. Whether the mysterious planet exists or not, this search redefines the solar system. If it's real, we'll redraw the Sun's dominion to include one more hidden world. If not, we'll rewrite the limits of our detection and correct our cosmic assumptions. Either outcome sharpens our understanding of gravity's reach and the architecture of creation itself. The coming decade will decide whether there's truly a stranger orbiting beyond Neptune, or whether the greatest secret of all is how our minds find meaning in the dark. If you love unraveling the hidden, the mysterious, and the cosmic unknown, don't forget to subscribe to The Enigmatic, where every story takes you beyond the stars.